Welcome to Nugget 242 with Steve and Dana Groman, and we will be doing an article from the Scientific American, April 2022. We haven't done a magazine article in a while.
No, this is going to be good.
Yeah, and if you haven't listened to our past nuggets about the questions that the students asked, you might want to go back and review that. But now to this article. It's called Flying Tiny, a speck-sized beetle turns flight mechanics upside down. Well, isn't that like God to turn things upside down when they discover them?
Happens all the time, doesn't it?
Yes, it does. When it comes to insect flight, bigger is usually better. As wings shrink, air friction overwhelms flight power. That's why dragonflies soar as houseflies sputter. But a beetle, the size of a grain of sand, flips this maxim on its head. It reminds me of the bumblebee.
He's not supposed to fly.
No, his wings actually are kind of funny compared to his body, aren't they?
Right.
Well, let's go on. The feather-winged beetle, less than half a millimeter long, I'm not even sure how they saw this guy, right, is smaller than some single-celled amoebas. At this scale, air becomes syrupy, and scientists once believed the beetle simply drifted wherever the wind blew them. That would be reasonable, wouldn't it?
It is absolutely reasonable.
But the new research in Nature shows how they wield lightweight wings to keep pace with species 3 times their size. I guess this is a picture. He's pretty gnarly looking. As the name suggests, feather-winged beetles sport bristled feather-like wings. These porous appendages are light and produce less friction than the typical membrane-based wings that flies have, helping the beetle generate lift. Multiple insects lineages, including parasitic wasps, have evolved similar wings as they downsized. Downsized from what? Maybe pre-flood?
Yeah, that's kind of what I'm thinking. The whole evolved. God made some really special things.
And if they're smaller because they're downsized, it's just because they're post-flood.
It's just they're post-flood.
Interesting. But these beetles use a previously unknown strategy to generate their outsized flight power, according to the new study's authors. In 2017, the research team collected feather-winged beetles from bits of fungus in a Vietnam jungle. You know, which reminds me, we just went to the store a minute ago, and there were 2 gentlemen, and they were sporting Vietnam veteran caps, and I was actually able to say thank you to the one he had on his cap, that he was a combat veteran. I want to encourage you to do that. When you see these gentlemen, you don't know what they've went through and what they've struggled with in their lives. To give those of us an opportunity to continue on, they gave a major part of their youth to that war. They deserve at least a comment. Tell them thank you if you see someone like that. Back to this fungi in Vietnam.
You see them just about every day.
Well, I'll try and say something or shake their hand if I can.
Just about every day.
To record the insect's infinitesimal flight patterns, experimenters placed the creatures in a transparent chamber and filmed them with 2 high-speed cameras at nearly 4,000 frames per second during a battery of tests. They used these recordings to construct 3D models of the diminutive beetle and calculate its aerodynamics. Just fascinating what technology can do.
It is fascinating.
The team found that instead of flapping their wings up and down, feather-winged beetles loop them in a remarkable figure-8 pattern, says study co-author Kolomensky, a physicist studying fluid mechanics at Moscow's Skolovo Institute of Science and Technology. After the bristled wings unfurl from their protective cases, known as elytra, they mirror each other as they move, clapping together both in front of and behind the insect. The motion is reminiscent of an extreme version of a swim stroke used as the butterfly.
What's interesting is they never went to school, but they know how to do it. God told them what to do and how to do it.
The amazing creation that God gave us.
Fascinating.
And he goes on to talk about how it patterns the swimming and that he's intrigued by that. Typically, this type of paddling is seen in small aquatic crustaceans such as water fleas. And you know, I think that they would, they're not going to in this article, but they would say that's just part of because they're all evolving and they're all coming and they're all using that. But you would say that it's because
that's the way God made them, number one. It seems so simple, but man reproduces what God has done over and over, whether it is an item like spider silk is strongest of anything, all the way down to movement. It is amazing to me how man, when they need to improve something, they do what God did naturally.
And that's what they're going to finish this article with saying, is they say their findings may influence how engineers shrink flying technology.
Yeah.
Although he admits it would take a major engineering feat for a drone to approach the proportions of a feather-winged beetle. Probably not as small, he says, but that's to be explored. Sometimes you just can't copy what God did.
No, you cannot make it as good as he did, that's for sure.
All right. Well, thank you.